Hey there, ever stop to think about your own personal superpower? Because you have one, and you use it every single second of every day without even noticing. It's your attention, that incredible, almost magical ability to pull one single tiny detail out of a whole world of chaos. Today, we're going to dive into how that actually works.
So let's just ground this in something we've all experienced. How do you find a friend's face in a huge concert crowd? Or how do you spot your blue phone on a desk that's covered in clutter? Your brain does this, instantly. And it's not magic, right? It's a really sophisticated biological process, and scientists have a fascinating leading theory about how it all goes down.
All right, so that theory is called the Feature Similarity Gain Model. Yeah, I know, it's a bit of a mouthful, so we'll just call it FSGM. But the idea behind it is actually super simple and intuitive. When you're looking for something, say that blue phone, your brain basically acts like a sound engineer. It turns up the volume on all the neurons that get excited about the color blue. It just cranks up the signal for what you're looking for, which makes all the other distracting stuff kind of fade into the background.
Now, for a long time, scientists could see this happening. They saw that when these specific neurons got more active, people got better at finding things. But, and this is the classic problem in science, right? Is that just two things happening at the same time, a correlation? Or is this whole volume boosting thing the actual reason you find your phone faster? Is it the cause? Proving that is a whole other level of challenge. So to crack that nut, researchers had to get really creative. I mean, you can't just dive into the billions of neurons in a living human brain. So instead, they built a kind of virtual lab. They decided to test their theory of human attention on a really powerful form of artificial intelligence. And here it is. This is the AI they used. It's a deep convolutional neural network known as VGG16. Now, the reason this is so cool is that this AI works as an amazing model brain. Why? Because it's designed to process images in layers, building up its understanding piece by piece, which, believe it or not, is incredibly similar to how our own visual system in our brain works. And you can see that process right here. The AI's first early layers are pretty basic. They just pick out simple stuff like lines and edges. Then you get to the middle layers, and they start putting those together to see shapes and textures. And finally, the late layers can take all that information and identify complex, whole objects, like a clock or a butterfly. See? It builds understanding, one step at a time. Okay, so the stage is set. The researchers have their model brain, they've got their theory about attention. So now it's time for the main event. Putting that theory to the test. The question was simple. If we apply this FSGM theory to the AI, can we actually make it see better? But first, you can't give the AI an easy test, right? You gotta really challenge it. So they designed these incredibly cluttered images. I mean, some have two different pictures merged on top of each other, others are a grid of four totally different images. For a computer, trying to find one specific thing in all this noise is unbelievably hard. It was the perfect arena to see if a little artificial attention could make a difference. And this is where the rubber meets the road. The scientists went into the AI's virtual brain and did exactly what the FSGM theory says our brains do. If they told the AI to look for a clock, they would artificially turn up the volume on all the neurons that had learned to recognize clock-like features. And they did this across all the different layers of the network to see where it would have the biggest impact. So they ran the tests, they crunched all the numbers, and what they found was, well, it was a major clue. It was the first real, solid breakthrough in this entire investigation. And the result was a huge yes. I mean, look at this graph. Applying the attention model made the AI way, way better at finding the objects. But here's the really fascinating part, where it worked best. The performance boost was so much stronger when they applied attention to the smarter, later layers of the network. You know, the ones that understand whole objects, not just basic lines. This is an incredible parallel to what scientists see in our brains, where attention has the strongest effects in higher-level visual areas. So this was massive. This was the first piece of causal evidence, not just correlation, but cause, that this feature similarity gain model could actually be the real mechanism behind attention. It was such a neat, tidy answer, or at least it seemed that way for a minute. Because, like in any good mystery, as the scientists looked even deeper into their data, they found a plot twist. It turns out that what a neuron is naturally built to like seeing, that isn't the whole story, not even close.
Okay, to really get this twist, we need to separate two key ideas. On one side, you have a neuron's tuning. You can think of this as its preference, what it's built to respond to. So you might have a neuron that just loves seeing vertical lines. But on the other side, you have its function, and that's all about what's most useful for the specific task you're trying to do right now. So if you're looking for the letter T, yeah, boosting that vertical line neuron is helpful, but you also need to boost the horizontal line ones. Function is about strategy. And here's the big reveal. The researchers compared a neuron's tuning, its preference, to its actual function, its usefulness. And they expected these two things to line up perfectly. But just look at this graph. The connection was shockingly weak. A neuron could be super tuned to clocks, but actually be not very useful or maybe even harmful to the goal of finding a clock in a messy image. The simple, elegant theory was incomplete. This shocking result led them to a brand new, way more nuanced idea. The way they put it in their paper is just perfect. Biological attention might be applied at least in part to optimize function rather than strictly according to tuning. In other words, maybe our brain is much smarter than we've been giving it credit for. Maybe it doesn't just blindly amplify what its neurons prefer, but instead, it intelligently figures out what is most functionally useful and boosts that. And just like that, the entire investigation leveled up. They thought they had solved one mystery, but instead, they just stumbled upon an even deeper and more profound one. The story wasn't ending. It was just getting to the really good part. So this leaves us with this huge, amazing question about our own minds. Is our attention just a simple, knee-jerk process that amplifies what our neurons are already built for? Or is it a smart, flexible, and strategic system that actually changes its whole approach based on what we're trying to accomplish? And you know, the beautiful thing about science is that a new question just means it's time for a cool new experiment. The researchers have already proposed the perfect way to test this. The next step is this really elegant experiment designed to see if our attention changes its strategy when the goal changes, even if the thing we're looking at stays the same. The hunt for an answer is already on. Which just leaves us with this one last incredible thought to chew on. This whole discovery was only possible because we used an AI as a model for our own brain. So if teaching an AI how to pay attention can unlock these kinds of secrets, what other profound truths about ourselves is it waiting to help us uncover?